Hi everyone, we're going to evaluate this integral. We're using in the table of trigonometric substitutions, which is basically the inverse trig functions. And it has this square root has this form. So our a is basically the square root of 9. So on this one, what we're going to do is for our substitution, is let x equal 3 secant of theta, with this being our restrictions. We're either in quadrant 1 or quadrant 3. So let's take our derivative. That's going to be 3 secant theta tan theta d theta. Now we can look at this piece. We're just looking at this piece and plug in our x. So we'll get, for x, we square it, we get 9 secant squared theta minus 9 equals the square root of 9 times secant squared theta minus 1. And that's going to give you, you pull out 3. Now secant squared theta minus 1 is tan squared. So your square root of tan squared theta. So that's going to give you 3 secant theta. Because secant theta is positive in these two quadrants, we can take away the absolute value signs. So now let's do our substitution. So we get this equals 3. This is what we're substituting in for the numerator. 3 tan. Well, that should be tan here. Sorry about that. So this should be tan. So 3 tan theta divided by, and our x cubed, plug that in, and you're going to get 27 secant cubed theta times our dx, which is this. So that's going to be 3 secant theta tan theta d theta. Now, you multiply the constants. So that's going to be 9 divided by 27, which is 1/3. So pull that out. And let's simplify all of this. We have 2 tans. So that's going to be tan squared theta. And this will go into this secant one time. So you're going to get secant squared theta d theta. All right. Now let's simplify this. This is sine squared over cosine squared divided by, that's square here, divided by 1 divided by cosine squared theta. So these two cancel and you just get sine squared. So we're left with 1/3 the integral of sine squared theta d theta. Now, anytime you have this with the trig functions, we want to use our half angle formula. So we want to let sine squared theta equal 1/2 1 minus cosine 2 theta. And that's going to make it easier to integrate. So if we substitute that, we're going to get 1/3 integral of 1/2 1 minus 2 cosine 2 theta d theta. Now pull out this, so that's going to be 1/6. And let's go ahead and integrate this. So that's going to be theta minus, let's see, that's going to be 1/2 sine 2 theta plus c, which basically equals 1/6. And I'm going to expand this. This is going to be 1/6 theta minus 1/12. And sine of 2 theta is 2 sine theta cosine theta. And then we still have r plus c. So this is going to end up being 1/6. So let's take care of that. We have, when you take care of that, you're going to get 1 divided by 6 theta minus 1/6 sine theta cosine theta plus c. Now the problem is on the indefinite integral, we started with x, but now we have thetas. So let's draw a right triangle and put our angle here. And we had the x equals 3 secant of theta. So secant of theta equals x divided by 3. So that means secant is going to be r, or your hypotenuse, over your adjacent. And when you do the Pythagorean theorem, you're going to get x squared minus 9 to get this side. So we're going to fill everything in. So for this, we're going to get, for our angle here, looking at this, we know that x divided by 3 equals secant theta. So theta equals inverse secant of x divided by 3. So that's what we're going to fill in there. Minus 1/6, and then we're going to multiply. So sine is opposite over hypotenuse. So that's going to be square root of x squared minus 9 divided by 6. And cosine is adjacent over hypotenuse. So there you have that. So cleaning that up, and you still have your plus c. Cleaning that up, you're going to get 1/6 inverse secant x divided by 3 minus, and we've got this 3x here, so that's going to, we have the 1/6, so when you multiply these two, that's going to end up being 1/2. So I'm going to write x squared minus 9, and we have the 1/2, so I'm going to put the 2 here, and that's going to be x squared plus c. And that's your final answer. Thank you. Have a nice day. Bye-bye.